Hello everyone, my name is Marijon Igot. Today I'll be discussing three topics in computer networking. This presentation aims to provide an overview of networking fundamentals, including different types of networks and topologies, as well as the network models that have been developed to help us understand how networks function. And by the end of this presentation, we will learn more about networking fundamentals and the key ideas that make computer networking work. Okay, so the three main topics that I'm going to discuss is number one is the networking fundamentals. Number two, we have network types and topologies. And the last one, the network models. First, let's talk about networking fundamentals. So what is this all about? So networking fundamentals refers to the foundational concepts and principles of computer networking. So it includes a range of topics such as network protocols, network topologies, network models, network devices, and network security. So these concepts help us understand how data is transmitted and received over computer networks and how different devices and systems work together to create a network. What is a network? A network is a group of computers and other devices that are connected together so that they can share information and resources such as files, printers, and internet access. So by connecting computers together, users can share data or communicate with each other and work together more efficiently, even if they are located in different parts of the world. Computer networks can be wired or wireless and can range in size from small local area networks or the LAN to a large wide area networks or the WAN that span multiple locations. What is a computer network? A computer network is essentially a group of computers that have been linked together so that they can share resources and communicate with each other electronically. These computing devices can be connected in a number of ways, such as through cables or wireless connections, and the connections can be established with a single building or across multiple buildings or even across different continents. By the way, a network can refer to any group of connected devices, while a computer network specifically refers to a network made of computers and other computing devices. Now let us proceed and discuss the components of a network. So in a computer network, there are two main categories of devices. So the first one is the end devices, and the second one is the intermediary devices. So let us discuss this one by one. Let's talk first about the end devices first. End devices are devices that are used by end users to access the network and communicate with other devices. They are the source or destination of data in the network. So these are the examples of the end devices. So we have computers like desktops, laptops, or tablets. So we have smartphones, servers, printers, and iPhones. So as you can see here, these are all examples of the end devices. So we have the computer, the laptop, the printer, and the iPhone. And we also have the wireless tablet, and the telepresence endpoint. The second component of a network is the intermediary devices. So intermediary devices are devices that connect end devices to the network and provide services to enable communication between end devices. These devices do not generate or terminate data, but they ensure the smooth flow of data between devices. So these are the examples of a intermediary devices. We have the switches, the routers, the firewalls, hubs, wireless access points, and the modems. So as you can see here in our example photo here, so we have the wireless router, the LAN switch, the router, the multi-layer switch, and the firewall appliance. So these are the examples of the intermediary devices. Next, let's talk about representation of network devices or components. Okay, so this refers to the various ways in which these devices or components can be visually represented in network diagrams or topologies. So they can be represented using symbols, shapes, or icons that help network administrators understand the topology and connectivity of the network. So as you can see here in our example here, so we have here the router. So this is the icon used. So this is what it looks like, router. And then next we have the LAN switch, and we have the LAN hub, the server, desktop computer, the laptop. So this is what it looks like, laptop, and the firewall. We have the IP phone and the wireless access point. See, this is the icon of the wireless access point, and the wireless router, this one. And we also have here a WAN media, which is represented by a I think this is a diagram or symbols like a Z. We also have the LAN media, represented by a straight line symbol, this one. And we also have the wireless media, and this is the symbol. Okay. Now let's talk about applications that uses a network. So what are the different applications that uses network? There are many applications that use a network, and they can be classified into a different categories based on their functions. Some of the most common applications that use a network includes, number one is the communication. So like email, instant messaging, video conferencing, voice over, and other communication applications rely on networks to transmit data between users. So the second one is the file sharing and storage. Applications like Dropbox, Google Drive, and OneDrive allow users to store files in the cloud and share them with others over a network. So number three, we have the web browsing. Web browsers like Chrome, Firefox, and Safari use networks to access websites and retrieve information. Number four is the social networking. Social media platforms like Facebook, Twitter, and Instagram can use networks to connect users and share content. So number 5 is the online gaming. Multiplayer games like World of Warcraft, Fortnite, and Call of Duty rely on networks to enable players to compete and interact with each other. Number 6 is the remote access. Applications like Remote Desktop, TeamViewer, and VNC use networks to allow users to access computers and servers remotely. Number 7, we have the e-commerce. Online marketplaces like the Amazon, eBay, Alibaba rely on networks to connect buyers and sellers and facilitate transactions. So the last of our examples is the business applications. Enterprise resource planning, or the ERP, customer relationship management, or the CRM, and other business applications use network to share data and coordinate business processes. So these are just a few examples of the many applications that use networks. So as technology continues to advance, new applications will emerge that rely on networks to function. Okay, so let's proceed with the second main topic, which is the network types and topologies. So first, I'm going to discuss the different types of networks. So the different types of networks are, number 1 is the local area network, or the LAN. And number 2 is the wide area network, or the WAN. And the last is the metropolitan area network, or MAN. So I'll be discussing this all. So let's talk first with the local area network, or the LAN. Okay, so local area network is a network that is confined to a relatively small geographic area, such as a home or office, like this. Okay, so LANs typically use Ethernet or Wi-Fi to connect devices to the network. Next is the wide area network. So a WAN is a network that covers a larger geographic area, such as a city or a country. Now this is an example of a WAN, or the wide area network connection. So as you can see here, this is our example here. Okay, so WANs typically use leased lines or satellite links or the internet to connect devices to the network. The last type of network is the metropolitan area network, or MAN. So it is a network that covers a larger area than a LAN, but smaller than a WAN, typically covering a city or town. So this is our example here. So this one. So MANs, or the metropolitan area networks, are often used by businesses or organizations that need to connect multiple locations together. Okay, now let's proceed with our subtopic, which is the network topology. So what is a network topology? Network topology refers to the physical layout of the devices on a network. So this is an example of a network topology. So this one. Okay, so there are 5 main types of network topology. So number 1 is the bus topology. So number 2 is the star topology, the ring topology, the mesh topology, and the last one is the hybrid topology. So I am going to explain these topologies one by one, and demonstrate by creating each type using the Cisco packet tracer. So let's talk first about the bus topology. Bus topology. So in a bus topology, all devices are connected to a central cable called the bus. Data is transmitted over the bus to all devices, and each device receives only the data intended for it. So I'm going to explain, or I'm going to do the demonstration about bus topology using the Cisco packet tracer. Okay, so since our Cisco packet tracer is now open, so let's proceed with our demonstration of the bus topology. So for this demonstration, I'm going to use 5 PCs, 3 laptops, 1 printer, and 3 switches. So let's proceed. So use the switches first. Okay, we'll use this one. So 3, and then the 5 laptops and devices here. So put it here, 1, 2, 3, 4, and 5. So laptop, I think this one PC is here. Okay. So the printer, this one. So let's connect the end devices to our intermediary device, which is the switch. Okay. Using the cable, copper straight through cable. So this one. Okay. This one here. Fast internet. We can use also the auto method in connecting the cables. Just click this one, this automatically choose connection type. So this one, see, it is much faster. Oops, we are in the real time, so sorry, switch it to simulation mode. This one. Okay, so they're all connected together, and as you can see, we have two lights, the green lights and the amber lights. So the green lights indicates that the connections are okay, or the connection is successful, while the amber light, it indicates that there's a problem with the connection. But we are still waiting here, maybe for some time, or 30 to 40 seconds. So we're going to wait for this amber light to turn green. And I think that in real-time mode, it is much faster, this amber light to turn green. So let's try it. See? Now, let us wait for these two here. Okay, so this is what we call the bus topology. So we're going to label it first, bus topology. Okay. So as you can see, they are all connected in a central single cable. This one here. So let's proceed with another topology. Next is the star topology. So in a star topology, all devices are connected to a central hub or switch. Data is transmitted from one device to another through the hub or switch. So once again, I'm going to demonstrate this in the Cisco packet tracer. Okay, so this is the demonstration for the star topology. So let's make a level first. I think this one, star topology. Okay. So in this demonstration, so we are still doing the same using 5 PCs, 3 laptops, and 1 printer. But we're going to use 4 switches and 1 hub. So let's do this. So let's find first the hub. This one, put it in the center like this. Okay, center. Okay, then the switches. Okay, so 1 here, 2, 3, and 4. Okay. Okay, let's minimize the space. Now for the 5 PCs and 3 laptops and 1 printer. So I think 1 PC pair with the laptop, I think. Okay, and 1 other PC here, pair also with laptop, 1 also here. Let's pair again with another laptop. So 1, 2, 3 laptops already in use. So we still have 2 PC. So let's put it here. And the printer, I think, here. So okay. So now we're going to connect the end devices to the switches using the faster method, this one, the automatic method. Make it faster. Oops, sorry. It's okay, it's okay. It's okay because we will connect that there later. Okay, so let's connect all the switches to the hub. think let's move, 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 move. Let's do just adjust. So okay. Okay, so now we're going to wait for this amber light to turn green. So again, I think I'm going to switch it to real time because I found it more faster than the simulation method. Okay, 3 more left. Okay, this is our star topology. Okay, now let's move on to our next topology. Let's proceed with the ring topology. In a ring topology, all devices are connected in a circular loop. Data is transmitted around the ring from one device to the next until it reaches its destination. So again, let's do this in the Cisco Packet Tracer demonstration. Okay, now let's proceed with the ring topology. Okay, so for this topology, we will use again five PCs, 3 laptops, and 1 printer, and we also use 4 switches. Okay, so let's level first. Ring topology. Okay, so let's take out first the switches. 4 switches, 1, 2, 3, and 4. Then the devices, PC, use laptop here, and then another laptop here, PC, 1 PC and laptop, then one. Okay, so we use the 3 laptops. So 1, 2, 3, 4, 5 PC again, another one here, and the printer. Okay, we use printer. Okay, so let's connect. again and do simulation. Okay. Okay, so now it's time to connect the 4 switches using our copper crossover cable. Okay, done. So this is our ring topology. So let's just wait a little bit. Let's try to switch in real time. See, 3 more to go, but I think we should not wait to turn all the amber lights to turn green, because we have still many topologies to demonstrate. So I think I can show it later. So this one to turn green after maybe our next topology, like this one here. See, they're all green. So let's move on to our next topology, the mesh topology. So in a mesh topology, each device is connected to every other device on the network. This provides redundancy and ensures that if one device fails, data can still be transmitted through alternate routes. So I'll show you this one in the Cisco packet tracer. Come on. Okay, mesh topology. So the same number of devices and intermediary that we are going to use in this demonstration. Okay, so let's go. Okay, again, let's find the right switch. I think this one. Okay. Okay, so now for the end devices, again, we will use 5 PCs and 3 laptops. Uh-huh. Printer. Okay, so it's time for us to connect. Okay, this time we will use the faster method of connecting the cables. I'll use this automatic. Okay, so now we're going to connect the switches, the 4 switches, using the mesh topology type. Connect it here. And then okay, so okay, so this is our mesh topology. So let's move on to the next topology. Okay, now the last type is the hybrid topology. A hybrid topology is a combination of two or more of the above topologies. For example, a network may use a combination of bus, star, and ring topologies to provide redundancy and optimize data transmission. So to understand this better, so let's proceed with our demonstration on the Cisco Packet Tracer. Okay, so this is our last demonstration, the hybrid topology. So for this topology, I'm going to use the combination of a bus and a star topology. So let's begin. We will use first the switches. So I think 3 switches, 2 and 3. Okay, then the end devices. Okay, let's have PC laptop here, and a printer here, and another laptop and PC. Okay, and we're going to use one hub. Okay, this one. I think let's move it upward so we can have more space below. Okay. Okay, then we also use maybe 3 switches. This one, or do it like this. 2, and one more. 3. Okay, so let's have another PC. I think one, then one laptop here, and another PC here. Let's do it this way. Okay, so let's connect all the end devices to the switches. So using our automatic to make it faster. And then let's connect all the switches here to form the bus topology. So next we'll connect here, and here, here, so, and connect here. See? So let's move down a little bit. And okay. Okay, so this is our hybrid topology. So a combination of a bus topology here and a star topology here. Okay, so thank you, and let's proceed with our next discussion. Okay, so after those demonstrations, so let's continue with our next discussion about network protocols and communications. So what is a protocol? Okay, so in the context of computer networking, a protocol is a set of rules and conventions that govern the communication between two or more devices on a network. Protocols define the format and order of messages exchanged between devices, as well as the actions to be taken when messages are received. Okay, just like our example here. So this is a human protocol here, and this is a computer network protocol. Moving forward, let's talk about commonly used protocols. So what are these protocols? So number one, we have the HTTP, or the Hypertext Transfer Protocol. And the second one is the TCP, or the Transmission Control Protocol. And we also have the Internet Protocol, or the IP. And the last one is the multiple protocols. So I'll be discussing this one by one. So let's proceed with the HTTP, or the Hypertext Transfer Protocol. So what is HTTP, or the Hypertext Transfer Protocol? So HTTP is a protocol used for transmitting data over the internet. It is the foundation of data communication on the World Wide Web, or the www, and is used by the web browsers to communicate with the web servers. So HTTP operates on top of the TCP or the IP protocol suite and uses a client-server model where the client sends requests to the server and the server responds with the requested information. So just like our example here. So the client requests with the server and the server responds to the client. So this is what we call the HTTP or the Hypertext Control Protocol. The second commonly used protocols is the Transmission Control Protocols or the TCP. It is a protocol that provides reliable, ordered, and error-check delivery of data between applications running on hosts communicating over an IP network. TCP establishes a connection between two endpoints and manages the flow of data between them by dividing large data streams into smaller packets, tracking packets delivery, and resending lost or corrupted packets. So this is TCP in action here. The third one is the Internet Protocol or the IP. IP is a protocol used for sending data packets across networks, including the Internet. IP defines how data packets are addressed and routed from their source to their destination. So it is also responsible for transmitting packets reliably or best effort, depending on the service required. IP is the primary protocol in the TCP or IP protocol suite. The last one commonly used protocols, we have the multiple protocols. So multiple protocols refer to the use of different protocols within a network to perform a specific task. Networks typically use a combination of different protocols to handle tasks such as routing, addressing, and transport. For example, the Internet uses multiple protocols, including the TCP, IP, HTTP, FTP, and SMTP, each serving a different purpose. Multiple protocols enables networks to efficiently handle different types of traffic and ensure reliable communication between devices. Okay, let's move on to our last main topic, which is the network models. Oh, the first model that I'm going to discuss is the OC model. So what is OC model? The OC, or the Open Systems Interconnection model, is a conceptual framework that describes how information moves between devices on a network. See, so the model consists of 7 layers, each with its own specific set of functions. So this is the 7 layers of the OC models. So we will discuss, or I'm going to discuss this one by one. So let's proceed with the physical layer. So the first layer, which is the physical layers. The first layer of the OC model is the physical layer. This layer deals with the physical connection of devices to the network. So it defines the hardware, such as cables and connectors, used to transmit data over the network. The second layer is the data link layer. This layer provides error-free transmission of data frames between nodes on the same network segment. It also defines how data is formatted for transmission and how devices are identified on the network. Network layer is the third layer of the OC model. This layer is responsible for routing data between different networks. It determines the best path for data to travel based on network conditions and traffic. Move on to the fourth layer, which is the transport layer. This layer ensures reliable transmission of data between devices by providing error recovery and flow control. It also breaks down data into smaller units to be transmitted and reassembles them at the receiving end. Now let's proceed with the fifth layer, which is the session layer. This layer manages communication sessions between devices, such as establishing, maintaining, and terminating connections. It also provides synchronization and checkpointing services. Layer number 6 of the OC model is the presentation layer. This layer is responsible for data representation and encryption. It converts data into a format that can be understood by the receiving device and can also encrypt or decrypt data to ensure its security. The last layer, or the seventh layer of the OC model, is the application layer. This layer provides services to applications that communicate over the network. It includes protocols such as HTTP, FTP, and SMTP that are used for email, web browsing, and file transfer. Now let's proceed with the second model, which is the TCP or IP model. So the TCP or IP, or the Transmission Control Protocol or the Internet Protocol model, is a protocol stack that is used for the communication over the Internet. It consists of 4 layers, each with its own specific set of functions. The first layer of the TCP model is the network access layer. This layer deals with the physical connection of devices to the network. It defines the hardware, such as cables and connectors, used to transmit data over the network. It also includes protocols for the data link layer communication, such as the Ethernet. Okay, just like this one. This is the Ethernet. Moving on to the second layer, which is the Internet layer. This layer is responsible for routing data between different networks. It determines the best path for the data to travel based on the network conditions and traffic. It also provides addressing and packet fragmentation services. Let's proceed with the third layer, which is the transport layer. This layer ensures reliable transmission of data between devices by providing error recovery and flow control. It also breaks down data into smaller units to be transmitted and reassembles them at the receiving end. The protocols used in this layer include TCP, or the Transmission Control Protocol, and UDP, or the User datagram protocol. The last layer of the TCP model is the application layer. This layer provides services to the applications that communicate over the network. It includes protocols such as HTTP, FTP, and SMTP that are used for email, web browsing, and file transfer. It also includes protocols for other types of network communication such as DNS or the domain name system and DHCP, which is the dynamic host configuration protocol. That's all for the discussions of the main topics. Now let's proceed with the part 2 of this course project.